Hello, ladies and gentlemen. This is a lesson about interval notation for functions. Before we go over the interval notation for functions, you have to remember what original interval notation is, which, if you don't remember this from previous in the year or from an earlier year, here's a basic rundown of what interval notation is. What interval notation is it looks like a point almost, so it looks something like this. And what it does is the first thing tells you the beginning of the interval, and then it has comma, and then it tells you the end of the interval. And in general, that's just how you read it. The first thing's where something starts, comma, where something ends. And often with these in math, we're describing like what are the possible solutions or the possible values for something. You need to be familiar with this symbol here, the sideways 8, and that's the symbol for infinity, which means it goes on forever and ever and ever and ever without end. And negative infinity would be going on forever and ever and ever without end in the negative direction, whether that's down or left, if you're thinking about a coordinate grid or number line. And intervals also have special kinds of brackets on them. So this looks like a parenthesis, and you can call it a parenthesis, but it's also called an open bracket. And so you got your open brackets, which look like parentheses. But then there's closed brackets, and closed brackets look more like boxes, or it's boxed in. Open can also be called circular, or circular bracket. And then closed can be called square bracket. So you got open or circular brackets that look like parentheses, and then you got closed or square brackets that look like kind of like boxed ends of things. And the difference between the two is if it's open, that number's not included, but you get as close to it as you can. If it is boxed in, that number is the actual end of the interval. And that'll make more sense as we look at some examples. So if we have these examples here where we want to represent the numbers bigger than -2, well, if you're thinking about a number line and you got -2 over here and you want the numbers bigger than that, well, the leftmost part of our interval is going to start at -2. So I put -2 and then comma, and my interval is going to continue going on forever and ever and ever to the right. So I'm going to put infinity. And if I were to graph this answer, I would actually put an open circle. And if you have an open circle there, you're going to have an open bracket. So there's my interval for that one. This one here, and that'd be the numbers left of 4. Again, if I'm looking at a number line here and I have 4 here, and I want the numbers left of that, that means on the left part of my interval, it goes left forever and ever and ever. So it's going to start in the negative direction forever. So I'm going to put negative infinity. And then my 4 there, since it says or equal to, I would fill in this circle here with 4. So I'm going to put 4 here. That's the right end of my interval. And anytime you have infinity, it's always open because you can never reach infinity. But this 4 here is a filled in circle, and so that's going to correspond to a closed bracket. So open circle, open bracket, closed circle, closed bracket. It's pretty quick to match those up. So what I'd like for you to do is go ahead and write the intervals down for these two, pause the video, and go ahead and do that. I'll have you check. So our first one here, since it's the numbers less than -3, our number is going to start at negative infinity and then continue right until it reaches -3. Infinity is always open bracket. And then this 3 here, if I were to graph it out, would be an open circle. So this -3 is going to be an open bracket. Our k greater than or equal to 1 means the number's bigger than 1. So those are the numbers that go right forever to infinity. In the left end of this interval, the left end of my graph would start at 1. And since it says or equal to, the 1 dot would be filled in. It'd be a closed circle, so I use a closed bracket. And then infinities are always open. And then my last one here, it's all the numbers to the left of -75. So -75 is the right end of my interval here, and it goes left forever. Always open on negative infinity, and this -75 would be a filled in circle because it says or equal to. So you're going to have a closed bracket here. And so one quick way to tell whether you're going to have a closed bracket is if you have the or equal to on your inequality. And something else to notice is something can be negative and be the second option. Something can be positive and be the first option. So be aware that just because it's negative doesn't mean it's first. Just because it's positive doesn't mean it's second. It can kind of vary there. So later on in your notes here, you have some other examples with graphs. And if your graph has two sections where it's shaded, like you got two inequalities involved there, you're going to write out two intervals. And you're going to put a U in between them to say it's both of the intervals. Some intervals don't go on forever and ever. They just have a definite start and definite end. And so if I were to write my interval here, this goes between 3 and 6. So I put 3, 6. And my 3 here is an open circle. My 6 is closed. So I put my interval like that. What I want you to do is try and see if you can write out the intervals for these 3 here. Go ahead and pause the video and write those out. All right, let's check and see how things went. This first one here, it goes left forever, so you put negative infinity. And the right end of it is 2, so I put that. And the 2 is an open circle, so I put open bracket. This one here, the left end of my interval, the start of my interval, left to right, is -1. And then it goes right forever, so I'm going to put infinity. Infinity is always open. This is a filled-in circle, so I'm going to put a closed bracket on my -1. This one here has 2 intervals, so I'm just going to focus on the left one first. It goes left forever, so I put negative infinity, and the right end of it is 6. Infinity is always open, and the 6 is open, so I put open bracket. This second one, the left end of my interval is 9, starts at 9, and then it goes right forever, always open bracket on infinity, and this 9 dot here is filled in, so I put a closed bracket, closed circle, closed bracket. And then I need to put a U here to represent that both of these are part of the answer. It unifies them together. So now that you've kind of had this overview of just interval notation, we are going to move on to interval notation for functions. So with functions, you're not dealing with just a single number line, you're dealing with 2. So you have a vertical aspect to it and a horizontal aspect to all your graphs. And to write down the interval over which things are happening, you're always going to travel from left to right. So if you imagine you're a little guy here going on a hike. Let's say you got this guy here and you're going for a hike from left to right. Sometimes you're going up, sometimes you're going down, sometimes it's staying constant. Well, those different features tell you different things about the graph. And if I was going to write down the interval for which time you're going down, that would be in a little bit different fashion, but it's really similar to what we've been dealing with. And the way it works is if I want to figure out where this is going down, once again, imagine we have this guy and he's going from walk left to right. He starts by going up, and then at here, this point here, he starts going down, and then he stops going down at this point. So what you're going to do to write down your interval is you're actually going to go to your start point and draw a vertical line, and go to your end point and put a vertical line. And the reason you're putting a vertical line is so you can figure out what are the x values for which this is happening. And if you think of x as your time, you think about this. This is backwards in time, and this is forwards in time, and right now is your y-axis, or when x is 0. So here on the left side, at 1, 2, 3, 3 minutes ago, or x is -3, he started going down. And then he stopped going down right here, which is at x equals 1, or 1 minute in the future. So 3 minutes ago he started going down, 1 minute in the future stopped going down, and so that's my interval. I'm actually going to write out -3, 1. -3, 1, if you want to see it written out. And I'm going to put open brackets on that, because right at the top and bottom, he wasn't going up or down. So we're going to leave them open. So that's kind of how the process works. You're going to find the endpoint, draw vertical lines like these, and then that'll tell you the x values you're going to write down. So let's try out one for a different graph. Let's have you practice writing the interval for which this function is horizontal or constant, which is here, here, and here. That has 3 intervals. I want you to try writing out the second 2. I'm going to do this first one here, though. So my first one here, drawing my vertical line here, draw a vertical line here. It looks like I got this point here, which is at 5, and then I got this point here, which is at 10. So my interval for this first one would be 5 to 10. It is constant. All right, I want you to try and write out the other 2. Pause the video and do that. All right, for this one here, our vertical lines are not really necessary here because they're right on 13 and 16. So that interval is 13 to 16. But this interval over here where it's constant, where it's horizontal, draw my vertical lines. I got 21 and then 25. So my interval is 21, comma 25. I got my open brackets. Oh, wait. Oh, no. I forgot about this part here. If this were to keep going, if it were to do that, we would write infinity. It's actually looking like it stops there. It has an indefinite endpoint. So I'm going to change that back to 21 and 25 here. But if it were to go on forever, we would write infinity at the end. So it'd be 21, comma, infinity. So you kind of get this interval here. And something else to remember is if you have more than one interval, you're going to add a u to join them all together. So we got these 3 intervals together. All right, we got just a few more examples from the actual assignment. I want to kind of help you out, kind of show you what I'm looking for here. Let's jump to this graph, which is really similar to one we looked at the beginning. And I want you to write down the interval that makes the U shape where it's horizontal and the intervals where the function is below the x-axis. So this one here, that makes the U shape. Well, our U's here in the middle. So let's divide it up here, like that. So it's split, and this makes the U shape here. So I'm looking at -1, 2, 3. So this is -3. And over here on the right side, that's 1, 2, 3, 4. So that interval goes between -3 and 4. Remember, I'm just writing my x values, not my y values. I'm not going to put like 2, comma 3. It doesn't even have a vertical axis here. I'm just writing down my x's, the time from -3 minutes to 4 minutes in the future that u is happening. Now the interval where is horizontal. Well, this isn't horizontal until you reach the end. Well, this end part actually starts at 4. And then how far to the right is it going to be horizontal? Go ahead and finish the interval. All right, if you finish it up by putting infinity, congratulations, it is doing that. So it is horizontal from 4 to infinity. And then problem 6 here, the intervals, plural, where the function is below the x-axis. So here's my x-axis. Well, I got this section here that's below, and then I got this section here on the left that's below. And so we're going to kind of draw a vertical line here. This is not at a nice tick mark, and so we're going to do a little bit of guessing there. I'm going to go with about -4.2-ish. And then this one here, it does have a nice intersection here. It looks like it's right at 3. But this one here is a little bit to the left of 1. So a little bit left of -1, so maybe like -1.2 again. I can try -1.2, I guess. Yeah, so those are kind of different numbers there, but let's focus on this left one. This left section looks like it's got an arrow and it goes left forever, so I'm going to put -infinity. The right end of my section is right here where it crosses, so that's at -4.2. So I'll put that. And then I have another interval, so I'm going to put a U. And my other interval is here, which is going between -1.2 and 3. So I'll put -1.2, 3. I got my interval there. And voila, those are the intervals where this function is below the x-axis. So there you go. Hopefully that's a good understanding of intervals for you. It takes practice. Practice the assignment, check with the solutions, and build up that skill. Good luck.